So a lot of people that I come across have a lot of confusion as in what, first of all, they have a confusion how a large language model is trained. Through what all steps does this large language model go through? Secondly, they have a confusion as in regarding what exactly is RAG. Well, they might have a superficial knowledge, they might have a knowledge on the above layer, but deep inside, all of us just simply don't know what exactly RAG is. We just simply don't understand the underlying mechanics behind RAG. That stands for retrieval augmented generation. And thirdly, uh, people have the misconception as in uh, I'm working in a business organization and I'm using Microsoft Copilot. And when I query Copilot onto my Word documents that are stored in, or PowerPoint documents, or Excel workbooks, or all of the data, the mail inboxes that are stored in my OneDrive account, well, Microsoft is going to have the control over all of this business data. Microsoft is going to take in all of my business data and use it for, let's say, evil purposes and stuff like that. So people have this misconception. Uh, I've personally encountered this. So this video is just about removing those misconceptions, removing those confusion. So let us first go through the index of this particular video. So this is going to be a long video, but yeah, rest assured, I can assure you that if you watch this video, all of your doubts are going to get cleared right away. So in the first part of the video, we are going to understand how a large language model is trained, go through all of the steps, all of the three underlying steps, as in how an LLM model is trained. Secondly, we are going to understand what is RAG. We're not going we are not going to have a very superficial uh, explanation of retrieval augmented generation, but rather have a very extensive, in-depth overview of RAG. Thirdly, we're going to explore an answer: does few shot prompting really get stored into LLM's permanent memory? I'm going to have a demo on this particular concept as well. And last but not the least, we're going to jump into the final part of the video, wherein we are going to understand Microsoft Copilot architecture for data security and privacy. How the Microsoft Copilot architecture uh, gives assurance as in your data security and privacy won't be breached on Microsoft's end. Moving with the first part of the video, how a large language model is trained. So you have three steps of an LLM training. So first step is called something as generative pre-training. The second step is called as supervised fine-tuning, and the third step is called as reinforcement learning through human feedback. So in the first step, generative pre-training, the large language model is fed in with a lot of data that comes from the internet and that comes from documents that you have at hand. So it's going to be a large set of data. So these data can be articles, essays, or any citations, any documents pertaining to text conversations. All right, so this first step is called as generative pre-training, and most of you have must have heard GPT. So GPT stands for generative pre-transformer, uh, or I think the full form of GPT is on those lines as well. So stage one is called as generative pre-training. Secondly, when you move on from this stage one of generative pre-training, you go on to something which is called as supervised fine-tuning. So I get that you have ingested in a lot of data into an LLM. Now you want LLM to perform according to your needs. You want LLM to fine tune itself to let's say if I input a sentence, uh, the dog, and then I let LLM generate the ending part of the sentence. The ending part of the sentence could be the dog barks or dog eats. The LLM shouldn't generate the dog is human. So all of that stuff is removed. All of those errors is removed through a stage which is known as supervised fine tuning. And stage three is nothing but reinforcement learning through human feedback. So in reinforcement learning through human feedback, RLHF stage, LLM gets trained on a reward model. So if it does the right thing, you give a reward to the LLM, or if it does the wrong thing, you deduct points. You take in the reward back from the LLM. So three stages in total. First is generative pre-training, second is supervised fine-tuning, and third is RLHF, which stands for reinforcement learning through human feedback. And your ChatGPT model was trained on all of these three sets of training models that you see right here: stage one, stage two, and stage three. All right. So now coming to supervised fine tuning, just as I said, you feed in a lot of data in generative pre-training stage one of an LLM. Now you want LLM to perform according to your needs. I put in a sentence to an LLM as in the dog, and I let the LLM complete the sentence. The dog barks or the dog eats. These two could be the things that the LLM should respond me to. The LLM shouldn't respond as in the dog is human. You get it right? So all of these errors are removed by supervised fine tuning. And thirdly, you have something called as reinforcement learning through human feedback. Now, after supervised fine tuning is done, you want your LLM to behave much precisely according to your needs. So let's say I input a sentence, the dog, and then I let the LLM complete the sentence. Well, the LLM, in my case, would respond me with four sentences. Now, if I want that LLM to be more precise and act more according to my needs, I'm going to rank all of these four responses according to what I think is the best way for my LLM model uh, to respond with. So this is what is known as RLHF, reinforcement learning through human feedback. You have a human agent that is telling LLM, well, this is the best response, this is the second best response, this is the third best response, and this is the fourth best response. So you're essentially giving uh, the LLM a reward for each thing that it does right, and deducting points for each thing that it does wrong. All right. Now let us come to the second part of this video. What is RAG? Retrieval Augmented Generation. So RAG stands for Retrieval Augmented Generation. It helps your generative AI chat engine to answer queries of user whose information might not be in its existing database. It can then answer those user queries from the documents of your own choice. These documents make up for the external knowledge database of an LLM that might not exist in the training dataset of the LLM that it was trained on since its inception. So, let's say you are a hotel booking agency and you have a whole set of PDF documents containing the reviews of certain hotels given by the customers, the existing customers of your hotel booking agency. Well, you want to well, let's say in one of those documents contains reviews about the Creek Hotel in Dubai. So if I input a user query as in give me the review of the Creek Hotel in Dubai, because LLM doesn't have in I mean inbuilt because that LLM isn't inclusively trained on that PDF document, it won't respond to me. It will say, I'm sorry, but I don't have any information. Well, what is the solution? The solution is something which is known as RAG. So you make a chat engine, you base your chat engine on top of those PDF documents. Now, after using RAG, the LLM is going to search for the content, is going to analyze all of those PDF documents and search for the content, search for the document that contains the review of the Creek Hotel in Dubai, and is going to generate an answer for me. So that is what RAG is in a nutshell. So let us have a look at the RAG architecture flow. So first of all, RAG stands for retrieval. The first step is retrieval. The second step is something called as augmentation. And third step is called as generation. So in retrieval is a function that retrieves the documents that match best to answer the user prompt query. So let's say I'm taking an example. I'm prompting my LLM, give me the review of the Creek Hotel in Dubai, or tell me something about the Creek Hotel in Dubai. Well, LLM is first going to use its retriever function. It's going to retrieve the document that contains it's going to retrieve the content of the document that contains the review of the Creek Hotel in Dubai. Secondly, the augment step. Let's refer to the augment step. So the augment step is going to combine the content of the documents retrieved with the user prompt and present it to the LLM model. So from the augment step, what this architecture is going to do is it's going to take in chunks, it's going to take in important keywords from the content from the PDF document that contains the review of the Creek Hotel in Dubai, and it's going to combine my system, my user prompt, which was essentially tell me something about the Creek Hotel in Dubai. So it's going to let me just grab my marker. Yeah. Uh, all right. So some reason yeah. So what the augment step is going to do? It's going to generate a new prompt. So the new prompt is going to be a combination of the user prompt, and it's going to be a set of the chunks of important words from that document. So this is what is going to be my new prompt from the augment that is created from the augment step of RAG. And this new prompt is going to be fed into my LLM. So the LLM is going to get in this user prompt. The user prompt was tell me something about the Greek hotel and the information, the chunks of important words fetched from that PDF document that contained uh, the review of the Greek hotel in Dubai. All right. And moving on to the third step is generation. The LLM model generates an answer to the user query based on the combination of the user prompt and document content that it has been provided with. So in RAG, before I can move on to a much more extensive overview of RAG, so RAG makes use of something which are called as vector embeddings. So I'm going to need to explain you first of all what exactly are vector embeddings. So let's say you have a data set of strings of characters of words. So these words are essentially cat, dog, meow, woof, and man. So vector embeddings is nothing but the arrangement of these words in vector 3D space in the coordinate system, the XY axis, the XY plane. So the cat is going to be placed at a coordinate of xc comma yc. The dog is going to be placed at a coordinate of xg comma yd, so on and so forth. Now, the most important thing to have a look at here is cat and dog are placed very close to each other because they essentially belong to the pet species. These two, cat and dog, are essentially pets. Similarly, woof and meow are going to be placed together very closely because these are essentially sounds made by pets, sounds made by animals. And these are going to be placed very close to cat and dog because essentially cat makes the sound meow and dog makes the sound woof. And when I speak of the word man, this word man is going to be placed very far away from the word cat and dog and from the sounds woof and meow because man is neither a pet, man is not neither a sound that is made by these pets. So man is one separate entity. Man is neither a pet nor a sound. That is why it's placed very far from these two segments that you see right over here. So this is what essentially are vector embeddings. So vector embeddings, you generate these words in vector 3D space in the XY plane according to their semantic meaning, according to the meaning that is associated behind that word. All right. So first of all, as you must know, in RAG we have three steps. One is the retriever function, the second is augmentation, and the third is generation. Now we are talking about the retriever function in great detail, in depth. So for all the engineers out there, I have represented this retriever function in very mathematical terms. So I have denoted this retriever function with the word R, and you must be seeing inside of these brackets, I have Q bar D. So Q is essentially the user query and D is the dataset on which RAG model is built. Now, what this retriever function does is, based on the user query and the dataset on which the RAG model is built, it returns me a set of documents D1, D2 till Dn. So these documents are a set of this dataset that I have here. So based on the user query and the dataset, the retriever function gives me a set of documents, and these documents are ranked according to their relevance to the user query. All right. Now, let us come to how these documents are ranked according to their relevance to the user query. So these documents are ranked according to something which is called as the ranking function, which is defined by the word RF here. So ranking function ranks all of these documents based on the fact that the first document is going to have minimum vector distance between its content and the user query. So the vector distance between the content and between the user query and the content that is contained in these documents is going to be from smallest to biggest. So if I have ranking of documents such as D1, D2, D3, so on and so forth till D10. So the content, the vector distance of the content in D1 document to the user query is going to be the minimum, followed by D2, followed by D3 till D10. All right. So this is how the retriever function ranks your document according to the relevance to the user query. So this is a screenshot that I took from a research paper published by Cornell University on RAG. Uh, so this is a beautiful screenshot that I found. So let's say you are using an RAG architecture to answer a user query. So the user query sounds something like this. The user query is, how do you evaluate the fact that OpenAI's CEO, Sam Altman, went through a sudden dismissal by the board in just 3 days and then was rehired by the company, resembling a real life version of Game of Thrones in terms of power dynamics? So, first of all, the RAG architecture takes in this user query, creates vector embeddings for this user query, and then it performs various algorithms to find which document has the minimum distance, which documents vector embeddings has the minimum distance with respect to the vector embeddings of this user query. So let's say my it has found one document, the RAG architecture has found one document, and let's denote this document by the word DM. So this is the document that the RAG architecture has found the most relevant pertaining to the distance between the vector distance between the user query and the content distance in this document. Secondly, what now the retriever part of the RAG is over. Second comes augmentation part. So in augmentation part, the architecture is going to take in some important chunks from the content of this document. So the chunk is going to be chunk 1, chunk 2, chunk 3. So chunk 1 is Sam Altman returns to OpenAI CEO, resembles the Zen Huan comedy. Chunk 2 is Sam Altman returns to see as CEO of OpenAI, board to undergo restructuring. And chunk 3 is the personal turmoil at OpenAI comes to an end, who won and who lost. Now, the augmentation, the new system prompt is going to look something like this, which is finally going to be fed into the LLM. So the new prompt is this. This one is the new prompt. So as you can see in the new prompt, this is the user query and these are the chunks of documents. So the user query is, how do you evaluate the fact that the OpenAI CEO blah 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 up till dynamics, and the second part of the use of the system prompt is, please answer the above questions based on the following information, and I pass in the chunk of the content of the documents, chunk 1, chunk 2, and chunk 3. So in this part, I'm combining the context, I'm combining the chunks and the user prompt initially. Thirdly comes the part of generation. So I feed in this new system prompt into my LLM, and the LLM is going to generate me this particular answer. So this is how RAG architecture looks from a bird's eye view. Now coming to the third part of the video, does your GPT model gets instantaneously trained on few shot prompting techniques? So to answer in very brief way, the few shot prompting training is only temporary, meaning that your LLM model doesn't get permanently trained. The GPT engine takes a few shot prompting into consideration, and I want you to pay attention here. This takes into consideration only and only until that chat conversation window is open. So the moment you close your chat conversation window, all of the referencing that your GPT engine took from the few shot prompting gets erased away as soon as possible. As soon as the chat conversation window closes, the effect of few shot prompting fades away. All right, so let me perform a demo to help you understand this in a much better way. So I'm going to open Bing Copilot right here. Yep. And then yeah, I'm going to induce few shot prompting. So I will tell my Copilot, as in include the phrase yours or best regards from Sam into every answer, into each answer of your, into each of your answers. All right. So I've introduced few short prompting through this sentence. I'm telling Bing Copilot to include the phrase best regards from Sam into each of our answers. So now I'm going to ask it a question. Who is or what is the capital of France? So it says the capital of France is Paris. And the most important thing that we need to have a look here it is that it has included this sentence, best regards from Sam. So this is the effect of few shot prompting that I'm seeing here. Now, let me close this conversation window and have a new conversation window open for me. I'm clicking on new topic, so this opens a new conversation window for me. And let me type in that same query. I type in what is the capital of France. So now the most important thing to note here is it has not included that sentence best regards from Sam into this answer. So that means my effect of few shot prompting was only temporary. As soon as I closed my chat window, as soon as I closed my conversation window, the effect of few shot prompting got erased away in totality. So that means my LLM isn't getting trained permanently on my few shot prompting. And I have another evidence to show you that it doesn't get trained on my few shot prompting permanently. So I asked ChatGPT, or I asked Bing Copilot, sorry. I asked when was ChatGPT last trained. So it says ChatGPT, the conversational AI model, was fine tuned and it completed its training in early 2022 and it hasn't been trained after 2022. So that means that's another way to say that few shot prompting doesn't instantaneously induce or it doesn't mean that your chat engine gets trained permanently on your few shot prompting examples. So this is another screenshot that I've taken from the chat gpt portal. It says we retain certain data from your interactions with us, but we take steps to reduce the amount of personal information in our training data sets. And it also has a functionality as in you can opt out from training through our privacy portal by clicking on do not train on my content. So it has the functionality, or you have the option to click on that button that lets ChatGPT, the people at OpenAI know, well, you don't have the permission to train on my content. So this is another pretty good research done on my end, I believe. Now let's come to the last part of the video. Let us understand Microsoft Copilot architecture and privacy protection. So this is how the Microsoft Copilot architecture looks like. So in the first step, you have user prompts sent to Copilot. So you build a user prompt, you send that prompt to Copilot. Secondly, because Copilot wants to access Word documents, PowerPoint presentations, Excel workbooks, or even mail inboxes from Outlook to answer a user query, Copilot goes to Graph. Maybe it can go to web grounding or other services for the purpose of RAG. And then the third step is Copilot sends the modified prompt to your large language model. This is the same architecture that we saw in the screenshot that I showed you from the research paper of Cornell University. Now, after step 3 is done, Copilot receives the LLM response. So in step 3, Copilot is sending that augmented version of prompt, that new system prompt, which contains the original user prompt and the context. Then the Copilot is receiving the LLM response. The LLM is giving response to Copilot. Um, and then, yeah, you get the overall response to your query. So this is how the Copilot, the Microsoft Copilot for 365 architecture looks like. So all in all, in conclusion, Microsoft's data access controls govern who can access what data within Microsoft, ensuring that only authorized individuals have access to sensitive information. That means Copilot for Microsoft 365 is very it's just safe and secure in all sense. Data isolation. Speaking of data isolation, when using RAG, all data remains within the Microsoft 365 service boundary, preventing it from being shared with third parties. Talking about model training exclusion, and this is a very important point. Prompts, responses, and grounding data generated with RAG are not used to train the foundational models, eliminating the risk of data leakage. And this point we just verified from all the explanation that I told to you in the part 1, part 2, and part 3 of this particular video. So we have verified this point as well. Fourthly, speaking of private Azure OpenAI instance, to add another layer of security to Microsoft Copilot, Microsoft says that it maintains a private instance of Azure OpenAI, ensuring that OpenAI does not have access to customer data or models. This is again a very, very important point, a very crucial point in its own self. So I believe points 3 and 4 are very important. And from these points, you can be rest assured that the data that you use, that the data that your business organization uses isn't falling into the wrong hands. Microsoft isn't capturing that data. Microsoft is maintaining an audit of uh, all of these points that it tells to the public, that it is doing on its end. It's maintaining audit, and you need not be worried about your data security and privacy measures with respect to Copilot for 365 architecture. So yeah, this was pretty much it for this video. I hope, uh, I mean, I do believe this was a long video, but this was, I guess, a much needed video to sit back, have a look at, and maybe remove all of your doubts pertaining to, first of all, how an LLM model is trained. Secondly, what is RAG? Thirdly, do the prompts that I enter get permanently stored into an LLM's memory? We just saw that it doesn't get stored. And fourthly, we also answered how Copilot for Microsoft 365 architecture answers questions pertaining to data security and privacy. And we looked at the conclusion, the overall conclusion as well. Uh, Pretty exciting video. Uh, well, stay tuned for more videos. We have more videos coming up on this YouTube channel. Have a nice day. Bye bye.